Hello everyone. Today I'll be explaining the program 3, that is to implement the Ethernet LAN using N, that is 6 to 10 nodes, and comparing the throughput by changing the error and the data rate. So here, as we have studied in the theory, Ethernet is the most widely installed local area network. It's a link layer protocol in the TCP/IP describing how network devices can format data for the transmission. So it touches both the layer 1 and the layer 2, that is physical and the data link layer. So Ethernet defines the two units of transmission, that is packet and the frame. Here, collisions are a natural occurrence on Ethernet. Ethernet uses CSMA, CD, all those techniques which you have studied in theory. Now, here, in addition to the program 1 and the program 2, here extra thing is we'll be creating a link between the nodes. So these are the nodes here. This is the instruction which you have to remember, which is a make LAN instruction. Here we don't connect it with the links just by adding this command in the TCL script. We will have the link which gets created, which is said to be the Ethernet. And this is the here the program we'll be finding out, comparing the throughput. So for the throughput calculations, we have the expression, the size divided by difference of the time, and to convert that into bits per second, we multiply by 8 and divide by 1000, we do it. And extra thing is one more is X graph. Here we'll be for the comparison purpose, we'll be using the X graph, which is to plot a program which is used to create graphic representation of the simulation result. So Ethernet was standardized, which is IEEE 802.3, and it has replaced the wired LAN technologies, and the data rate is increased from 10 MB to 100 gigabits per second by using fast gigabit Ethernet, all that. So remember about the IEEE specification. So this is a procedure. So Java -jar nsg 2.1.jar to invoke, then gedit filename.tcl to write the TCL script, then ns or to edit, then ns filename.tcl to execute the TCL code, then gedit filename.tr to observe the trace file, and gedit filename.awk to create the awk program. And this is the instruction to execute the awk program, which is awk -f filename.awk filename.tr, and which will be redirected into a file. Once we redirect that to a file, the instruction that is in the awk program, we have an instruction that is calculation of the throughput. Those values get stored in out3a, which will be later used to plot the graph. So after changing the data rate, this is done for the comparison. Initially we have a data rate of 10 MB, then we change it to 512 KB, and the bandwidth also changed from 10 milli to 50 millisecond. And once we have the program, we simulate it by using ns filename.tcl, and then we redirect that to out3b, and then for the comparison we do it in the X graph, and we observe the graph from the awk file. So once we go to the terminal window here, press the same Java -jar nsg 2. Go to the scenario and the wired scenario which you have already done, and place the node N0, N1, N2 and N3, N4, N5 and N6. And here in the Ethernet LAN, we don't have to connect it with the links. Just go to the agents, skip the step of link, go to the agents, place here TCP NOT, and then place the TCP sync to any of the nodes above and below, then connect it using TCP NOT and sync, and then go to application and connect it using FTP. Once we have this times you can give it in the code. In the parameter you have to save it as any name. I'll be saving it as 3, and also nam file. I'll be giving the same file just to identify it. Then click on done. Once it is saved, Then go to the terminal window. Go to the TCL and the code gets generated. In this code, now the thing is only the link definition. This will be, you will have to type it, which is the make LAN command to have the LAN, and also you have to change the program. So once you type that, you will have to save it in the folder and give the same name as 3.tcl and then click on save. So once you save it here, go to the terminal window. By using Ctrl C, go to your folder wherever you have saved your program. Then you can open that program. So once you open that program gets open. So this is, I have already typed the command, that is make LAN, and these are the nodes. You can have nodes from 6 to 10, 0, 1, 2, 3, 4, 5, 6, and this is the bandwidth which is changed. So 5 to 12 KB to 50 millisecond. You can have initial bandwidth which is 10 MB to 10 millisecond. So first I'll change it to 10 MB to 10 millisecond. Save it. Then all the other, you need not change the color here, only TCP, then you will be giving the time. So once you save it here, go to the terminal window, Ctrl C, and perform NS. So NS here 3.tcl. Once when you enter, you will get a window, NAM window, where you have to have, you can maximize this, you can go to the edit, and then you can edit these just to look better. Then also 0 here, 1 here, and also 5 here and 3 here. Then you can run this. So once after you run this, run the code, you can see that packets are moving here. And this is the Ethernet LAN. So these are the ports. So here, close this window. Go to the terminal window once again. Ctrl C. Here, in the terminal window now, once you have done NS, now the next task with respect to the opcode. Now open the opcode. You will have to type it gedit 3.awk. Once you type the opcode, this is the opcode which is already typed. Size is 0, start time, stop time is defined, throughput is defined at 0, initialization is the body part, event is $1, type is $2, size is $6. If event is plus, then if the time is less than start time is time. If the event is R, time is greater than stop time is time, which was explained. So it is the throughput calculation. So it checks whenever we have entered the NQ time. If it is less than the start time, it considers that as time, just to have within the limit 0.128. This is used, and also here receive time. So size will be calculated, and this will be in a loop, and the throughput gets calculated again and again, and it will be printed here again and again. So since it will be printed again and again, what we do is we cannot display that on the terminal window. Even if we display it on the terminal window, since there is a comparison, we have to plot it in the X graph. So we cannot take those from the terminal window directly to the X graph. So we use a redirect operator. So what we do here is, once we have the program run, awk file, once we have this awk command minus, which is 3.awk, and it is here 3.tr, we direct it to, by using the redirect operator, we the file. It can be out 3A. Once we redirect it to a file, you can go to your folder. You can check that in your folder there will be a out 3A file which will be created. So this will be a out 3A file. So which will have the throughput values and with respect to the time. So these are the throughput values. Now this is done for one set of values. Now go to gedit for the same program, and once again for the comparison we need one more set of values. Change this from 10 MB to 512 KB, and also change this from 10 milliseconds to 50 milliseconds. Once we save this, only those changes, save this. Once again you will have to do ns. Always remember, once you change in the code you have to do ns. Once you do ns, you will have this window where you will have to edit it. Once you edit this, once you edit this, you run this. So here you can see the packet transmission. So close this window. Once you close the window here, go to the terminal window once again and use that arc and save it in one more file, out 3D. So you will have one more file which is with the out 3D. So here also you will have the time and the throughput. Now to display it in the X graph, use graph. We have to use X graph space out 3A space out 3B. You will get displayed onto the graph. So you can see that red one is 3A and the green one is 3B, which shows that this is the axis is throughput with respect to the time. Time is in milliseconds and time is in milliseconds, and this throughput calculation is that we have multiplied by 10 power 8. So it will be in terms of the bytes. So which will be converted, multiplied 8 divided by 1000. So it will be in bits per millisecond. Later value will be converted. So this is about the throughput which will be obtained. We can change the background, we can view the name to the index, we can view the name to the plot, all that can be done. So this is what here the learning outcome is that whatever we have achieved here is knowledge of Ethernet LAN, and also we have analyzed the throughput by varying the bandwidth and the queue size, and also performance of the Ethernet LAN is studied by observing the throughput. That is about the program 3. Thank you.